Principles of Finance with Excel Modeling, copyright Lou Gaddis. Topic 4, NPV and IRR. Net present value, NPV, and internal rate of return, IRR, are measures used to evaluate investment decisions. They're used to ensure that an investment's return will exceed its cost of capital and create value for the firm or the individual. In this topic, we will apply NPV and IRR techniques to evaluate personal investment decisions. In later topics, we'll talk about how businesses use NPV and IRR to make decisions. So we'll start with definitions. Net present value, or NPV, computes the total present value of a given set of cash flows and given a certain discount rate. So we would set up an equation in which we take the present value of all future cash flows 1, 2, through n, which would be the last year of the project, including the first cash flow today, CF0. Take the present value of all those cash flows discounted at some interest rate R. That R is called the discount rate. The sum of those numbers is the net present value. And you would accept all projects that have a net present value greater than 0. Reject all projects that have a net present value that is negative. And the cost of capital is often used as that discount rate. The idea that whatever it cost you to finance your investment, say you had to pay some money up front today, cash flow 0, the cost of financing that investment, to the extent that it represents the risk of the project, will be often the discount rate. Now, IRR, this looks like the similar formula. It is. Actually, this is the present value of all the cash flows equals 0. Actually, the IRR is that discount rate. It's one single discount rate that ensures that the present value of all cash flows, in other words, the NPV, is equal to 0. So you can think of the IRR as the break-even discount rate. It's also considered the rate of return of the initial investment. And if you use IRR to rank investments, what you do is accept the ones that the highest rate, internal rate of returns. However, you must ensure that those internal rate of returns exceed the hurdle rate. Now, the hurdle rate is any rate which you determine is the minimum rate you require on a project. And many times that hurdle rate will also be the cost of capital. So you want to make sure the return on your project exceeds the cost of capital. So let's look at a very simple example. Say you have a project that's going to cost you $100 today and return $115 in 1 year. We can calculate the net present value of this investment by just taking the present value, cash flow, over 1 plus the discount rate. I'm going to anchor that discount rate. Raised to the period. So the present value of $100 received today is $100. The present value of $115 discounted at 10% is $104.55. Now again, the interpretation of present value, what that means is $115 received 1 year from now is equivalent to receiving $104.55 today, because you can take that $104.55, and if I earned my 1 plus my discount rate, I can have exactly $115 next year. So that's what it means to have the present value of $115 discounted at 10% is $104.55. Now if I sum this up, I get a sum of all my cash flows of $4.55. That is the NPV of this investment. And remember, our criteria is accept any projects that are greater than 0, therefore I should do this project. Now let's calculate something called the IRR. The IRR is the discount rate. It's this discount rate that makes this NPV equal to 0. So I can do a data, what if, goal seek. Let's set the NPV to 0 by changing the discount rate. When I do, I get a discount rate of 15%, makes this NPV equal 0. Now I'm going to cancel that out, and I'll just type in the number here. 15% is now my IRR of this investment. Remember, the IRR investment criteria says that you accept the investment as long as the IRR is greater than some hurdle rate. Well, let's just say that the IRR's hurdle rate is 10%. Therefore, I'd accept the project. Now, the meaning of the IRR is that the return on your initial investment. So look at this. We spent $100 today, and we got $115 a year from now. So my rate of return on my $100 investment is 115 minus 100, $15 divided by initial cash flow, 100. That's what 115 means, in addition to the break-even discount rate. Now let's talk about the meaning of the NPV. Now let's assume that this discount rate is also our after-tax cost of capital, which it often is, and examples we'll use later in the semester or the class. Now, if this is my after-tax cost of capital, so I can get a loan at 10% after tax, I would borrow $100 for this project. I would then pay back $110 next year. All right, so I'm going to finance my project at the cost of capital, say 10%. I'll pay back $110 next year to pay off the loan. 10% of 100 is $10. However, this project returns $115. So that extra $5 is the cost above the cost of capital. Or I'm sorry, it's the cash flow above the cost of capital. So this project is going to have an extra $5 after I pay off my cost of capital. That $5 received in 1 year, the value of that today is $5 over 1 plus the interest rate to the 1 power is $4.55. So the interpretation of the NPV, when the cost of capital is your discount rate, and there's a lot of good reason to argue it is it's the value created after paying off your capital providers. It's the present value of the excess cash flows generated after you pay off your capital providers. So that's an introduction to NPV and IRR. Let's look at a multi-year example. Say you have a project A and project B. Now they both cost $500 today, and you're deciding which one to do. So we're going to calculate the NPV and IRR of these projects. I'll take my present value of each cash flow divided by 1 plus that discount rate. I'll anchor that. Raised to the period power. Now notice when I take something to the 0 power, it's going to turn out to be 1. So it's going to be $500 over 1 plus r to the 0. Anything to the 0 power is by definition 1. So it's really $500 divided by 1. I'll then copy that down. You'll see the sum of all the cash flows is net 525, negative 525. That's my NPV. Now the present value of just the positive cash flows from year 1 to 5, all the cash flows after year 0 is $494.75. So one way of thinking about this project is it generates cash, the present value of its cash flows it generates is not $494. However, it costs $500 today, so I'm not going to do it because the NPV is 0. Now you don't actually have to create this column. In Excel, you could use the NPV function, equals NPV. I'll put in the discount rate. I'm going to anchor that, comma, cash flows. Now notice the NPV function says cash flow 1 or value 1. So I can only start at the first cash flow, not the discounted cash flow, the first cash flow. And then to calculate the net present value, you have to include the initial cash flow today. So there's my NPV. So to use the NPV function in Excel, it's a bit of a misnomer because the function itself is not the net present value. It's the value of all future cash flows. To get the real net present value, we need to then add, or in this case, subtract that initial cash flow. Now I could run Solver to figure out what the IRR of this investment is. As you might think, that it's going to be less than 8% since the NPV is less than 525. So I can do data, what if, goal seek. I can set that NPV equal to 0 by changing the discount rate. And what you see is it's at 7.67. The NPV of this investment is 0. However, I can use a function called IRR, in which you just highlight all the cash flows, including the initial one, and that gives me my 767. Now I can copy these formulas, since I anchored the discount rate, over to project B, and I can calculate the NPV and IRR of project B. And what you see is project B has an NPV of $43. It's positive, so I would do project B, I would not do project A. And another way of thinking about it is the project has an internal rate of return, an IRR of 12%. If my hurdle rate and my cost of capital are 8%, I would accept this project. And if this 8% if that were my cost of capital, I would say that this project's cash flows, after I paid off my capital providers, would provide an extra $43 in present value terms. Now notice, these two projects are nearly identical. If you actually look at the cash flows, they're just in opposite order. 50, 100, 150, 100, 250. I just reversed the order. 250, 100, 150, 150. So these cash flows add up to the same amount, except these cash flows are front loaded. So you have access to the cash earlier, and that creates the higher present value, and that's why this project is more desirable. So this is NPV and IRR. Now let's apply NPV and IRR to some investment decisions. Before we do that, let me just show you one more function, XNPV and XIRR. It's kind of an interesting function. In this case, we have a project that has annual cash flows of $4,000. However, it's going to pay $1,000 every 90 days. So even though it's going to pay $1,000 a year, it's really $1,000 every 3 months. Now, if we were just modeling this investment using annual periods, I'd say, well, I'd pay $13,500 today, and I'd receive $4,000. I'm going to anchor that every year for the next 5 years. Now, I can then calculate the IRR of that investment and the NPV of that investment. By taking the NPV, I'll put my discount rate in, comma. I'll then take all the future cash flows and then add that initial negative cash flow. So I can get a negative NPV of 402. So this looks like a terrible project, right? It destroys value. I won't be able to pay off my capital providers. And it doesn't provide a return that's greater than my discount rate or my hurdle rate. However, the cash flows are actually received every 3 months. So let's say the first cash flow is 12/1/2016. I just type that 12/1/2016 in Excel. And Excel is smart enough that if I copy the format of this and I say, let me add 90 days to it, that's 3/1/2017. And if I get all 5 years of cash flows, these are the actual payment dates if they're exactly 90 days apart. And then if the initial cash flow is spending $13,500, and then I receive $4,000, I'm going to anchor that, divide it by 4, because remember I said it's $4,000 a year, but $1,000 every 90 days. So the cash flows actually look like this. Now let's see if this getting access to, say, these cash flows a little bit earlier every year makes a difference in the IRR and NPV. So I'll calculate XIRR, which is the IRR when you use dates. When it says values, you put all the values, including today's, comma, and then it asks for all the dates. And then I'll hit enter. So the project with the more front-loaded cash flows, the idea that we don't have to wait this assumes we wait a year to get access to the first $4,000. This is we're going to get paid $1,000 in 3 months, and 6 months, and 9 months, and a year, then 15 months, and so on. The IRR is actually 1759, the actual IRR. And if we calculate the XNPV, where we put the annual discount rate, all the cash flows, including the first one, because the dates can handle the fact that it could be today, comma, and the date, I can get an NPV of 424. So this actually does return cash flows in excess of my cost of capital in this case. Now, one caveat. When this says net present value, the XNPV, that's a little bit of a misnomer. It's actually the net present value as of the first date. So it assumes that today is 12/1/2016. So it calculates the net present value on this first date. So if you have the cash flow timing, you should use them because it could make a big difference in whether you decide to accept. Now we're going to look at how NPV and IRR can be applied to a condo investment decision. So this is modified from the textbook. So say you're going to buy a condo for $100,000 today. Tax rate is 30%. In 10 years, you plan to sell it for $90,000. The straight line depreciation is going to be 27 years. So we're going to depreciate 1/27th of that $100,000 over the next 27 years. You expect annual rents of $24,000. Property expenses of $1,500, and miscellaneous expenses of $1,000. Now we're going to compute the full net income, cash flows, and NPV and IRR of this condo investment. So we'll go to our spreadsheet. If we're going to depreciate this straight line over 27 years, our depreciation will be the cost of the condo divided by 27. Now, the reality is, if you go to the IRS website, you're probably going to have to depreciate this over 27.5 years using their schedule, but this is close enough for now. So we're going to have a depreciation expense of $37.04, assuming we depreciate it over 27 years. If I then calculate my rent minus property taxes minus miscellaneous expenses minus depreciation, that gives me income before tax of $17,796. If I then take my earnings before tax and multiply times my tax rate, I get $5,338. So that's my net income, $12,457, assuming on amortizing this over 27 years. Now, if I want to calculate the cash flows of this investment, I know I'm going to spend $100,000 today. The question is, for the next 10 years, what are the cash flows, assuming that these are the relevant figures? Well, we have a net income of $12,457. However, these are not cash flow expenses. Rent is cash flow. Property taxes, we'll certainly pay that, and we'll pay the miscellaneous expenses. We will not pay depreciation. So depreciation is just a recognition of expenses to reduce your tax bill. So I'll actually add back the depreciation. If I then add the depreciation plus the net income, that gives me $16,161. That is my cash flow annually while I'm operating this condo, renting it out. Now in the 10th year, I plan to sell the condo. Now here's what happens on the sale of a condo or a sale of an asset according to the IRS. We'll say we'll get $90,000. Well, I can't just add $90,000 to the last cash flow because I'm going to be taxed on it. However, the tax rate is going to be, the tax on the sale is going to be the tax rate times the difference between the salvage minus the book value, where the book value is the cost minus the cumulative depreciation. So here's the formula for figuring out the after-tax cash flow from the sale of the condo. I'll take my $90,000 minus the tax on the $90,000, which is equal to the tax rate times the difference between what I sell it for, $90,000, and its book value, its cost according to the IRS at the 10th year, its cost basis, which is the $100,000 minus 10 of these depreciations. So the cumulative depreciation will be 10 times 3,700. It's about $37,000. So my cost basis is 100 minus $37,000. That's about $60,000. So I will be taxed on the difference between what I sell it for and its cost base and its book value. So if I take my last cash flow and add the after-tax salvage value or residual value, it's just what I sell it for at the end. These are my cash flows for my condo. I can then calculate my IRR of the condo investment. Don't include this. I'll be double counting. This one's inside this cash flow here. So it looks like a 15.28% IRR. I can then calculate an NPV by taking my discount rate, we'll just assume that's my cost of capital, comma, the cash flows after period 0, and then add in the first cash flow, and you'll see it should be positive, $17,680. So what that means is my rate of return on my $100,000 investment over the life of this asset is 15.28% per year. And if I calculate all the extra cash flows after repaying my 12% capital and taking the present value of all those extra cash flows, I get $17,680. Now I can do a sensitivity analysis. If I just do a link to my IRR and I set up a data table by highlighting this table that I set up where I have rents going from $18,000 to $28,000 and my salvage from $50,000 to $160,000. I can do data, what if, data table. My rows are my rents, so I'll put in rows. I'll put the rent. Now this has to be the rent that drives this net income, which drives these cash flows in IRR. And the column is the residual value, the salvage, what I sell the asset for it at the end. And now, notice there is my 15.28. I can change that cell style. Well, it looks like it better not. It looks like it makes it disappear. So here's my base case. I expect to get an IRR of 15.28, but the IRR could be as high as 20%, assuming I get maybe more rents and higher salvage value. And it looks like the worst case, if these are my worst cases, and I sell it for $50,000, I only get rent of $18,000, I get an IRR of 891. So this is how you can evaluate a personal investment in a condo, which requires you to calculate after-tax cash flows, which in this case requires a depreciation schedule. And then at the end of the asset's life, you have to decide whether it has a residual. If this asset is going to be useless, let's say the students trash my condo so much, it's only worth $16,000, these are my IRRs. However, if I can sell it for $90,000 and pay the taxes on the difference between the 90 and its book value, I'll make this IRR. Now I did highlighted these data points, and all I did here to give this a color is I did conditional formatting. And what you can do is you can set up color scales. Maybe you want to see blue had the highest positive numbers, and it gives you an idea where the good spots are. In this case, the blue are the highest values, and the red is the lowest values. So that's my condo. So let's look at another investment. But before we do that, let's talk about one more thing. This is actually going to help you with the assignment in this section. Now, what if I were to get a loan on the $100,000? So in this example from the textbook, Sally was going to do this condo. However, what if we finance the condo with a $100,000 12% loan, and we want to actually calculate the cash flows as the owner? Well, to do that, to figure out the cash flows, we're allowed to deduct interest from our expenses to calculate taxes. So we'd have to, as the owner of this, as the sole equity owner of this condo, I'd have to figure out if I get a loan at 12% per year, in other words, 1% a month for 30 years, how much interest will I pay in the first year? Because I can only deduct the interest from my taxes and not just the principal and interest. So let's go to the spreadsheet and talk about this loan. So I'm going to get a $100,000 12% loan that matures in 30 years, and I'm going to pay monthly payments. So that's going to be 30 payments, 30 years times 12 payments per year. It's going to be 360 payments. The annual rate is 12%. If I divide by 12, that's 1% a month. Now Excel has a payment function, PMT, where I put in the periodic rate, comma, the number of periods, comma, and then I can put in the principal, the present value of the loan. And if I hit enter, it gives me the loan will be $1,028 a month for 360 months. Now, usually what I like to do is put negative present value because I don't like to see the payment as a negative sign. So the payment's going to be $1,028. Let's talk about what Excel does to do this. There's a formula to calculate a level payment for a mortgage or a loan that amortizes like this. So when we talk about amortizing, what we're doing is we're trying to figure out if the bank wants to earn 1% a month, and we want at the end of the 30 years for the loan to be fully paid off. In other words, all the principal has been paid back. What is that one level monthly payment that does that? And it turns out to be that's $1,028. So look at the schedule I built down here. If the mortgage starts out at $100,000 for the first month, and the bank wants to earn 1% a month, it's going to charge you $1,000 interest on the first payment. I'm sorry, the first payment will be $1,000 of interest. Now the total payment's $1,028. So $28 goes to paying down principal. So if you go and look at the end of the first month, your ending balance is $99,971. Now the next month, the bank wants to get 1% every month. So 1% of $999.71 is $999.71. However, the payment is always $1,028. So the difference between the interest component and the total payment is $28.90. I subtract that from my balance. Now, if you keep doing this loan at the end of this 360th month is exactly paid off. The balance went exactly to zero. And actually, that last payment of $1,028 was $1,018 in principal and only $10 in interest, because it's 1% of the outstanding balance of $1,018. So Excel has built a function that calculates what is that monthly payment that includes both interest and principal, but it's a level payment that pays off the mortgage. And you can see that if I were to do this for my condo, my interest expense for the first year looks like it's $11,980. But how can we get this Excel to tell us the interest component in any one payment? Say the fifth payment, how much was the interest in just that payment? How much was the principal? Well, we can use the P payment and the I payment functions. If I say equals P payment, and I put in the interest rate, the periodic interest rate. Now period, that's going to be the fifth period, comma, number of periods 360, comma, and I'll put in my minus present value again. I'm actually going to highlight all this and anchor it using my dollar signs, hit F4. So my $29 is the principal part of the fifth payment. Now if I copy this down and change P payment to I payment, that's another function that uses the same parameters. $998 is the interest payment. Now here you can see my formulas I use. I use the P payment and interest payment. And to get the ending balance is always just the beginning balance minus the principal payment. So this is how you can calculate build a 30-year loan schedule. And you'll know any day that you end this loan. So say after the 50th month you want to pay off the loan, you still owe $98,155. That's your payoff amount. At the end of the 100th month, you owe $95,000. So in the case I give you on the assignment, one of the last assignments, is part of it is you have to redo sort of this type of exercise. It's a little more complicated because it's annually, but one of the expenses becomes interest expense. And that's going to force you to calculate the annual interest expense. So let's do another analysis, a personal financial analysis using IRR and NPV. So here's a crazy one. What if the winner of the 2014 South Carolina lottery was given a choice of $223.7 million lump sum payment today, one-time payment, or a 30-year annuity starting today? The first payment was going to be $7.1 million, and that annuity grew by 4% a year. So you're going to get 30 payments. First one's $7.1 million, and then that payment grows by 4% a year. Let's assume no taxes. And let's assume that the investor can invest at 3%. We're going to use that as our discount rate. And now we're going to calculate the NPV of either taking the lump sum or the annuity. Now I have a discount rate in here of 3.65%. I'll explain why later. Let's assume, again, the lottery was, a winner was given the choice of the $7 million growing at 4%. So these are the choices. I get $23 million today, or I get $7.1 million today, and that $7.1 million grows at 4%. I'm going to anchor that. So if I don't take the lump sum, I get this series of cash flows. Now let's calculate the NPV. Now the NPV of $223 million today is $223 million. I don't have to really calculate the NPV to do that. The NPV of the annuity, I'll put my discount rate, comma, put in the cash flows from period 1 to the end, and then I'll add the first cash flow. So it looks like I should be indifferent between taking 223 today or taking this series because it has the exact same NPV. Now if I subtract the two NPVs, you can see the difference is 0. Now let's do something else because I think it'll be interesting to think about what the NPV even means and the discount rate means in this case. Let's take the difference between the annuity and the lump sum. So you can think about this. This is the net cash flow from deciding to go from lump sum to annuity. So it's modeling the decision of not taking the lump sum, but taking the annuity over the lump sum. So these are the difference between the two. Now if I take an IRR of choosing the annuity over the lump sum, I will get 3.65%. That's why actually I plugged that in there for now. And if I were to calculate that NPV, using that 3.65%, I guess I can discount and I'm sorry, then I'll put in my cash flows, my incremental cash flows, and add the first cash flow. My NPV is exactly 0. So I would be indifferent between 223 or receiving 223.7 today and this annuity if the discount rate were 3.65%. But in this case, let's think about what that means. What if I decided to take the annuity? I would take my annuity, but what if I really wanted I took the lump sum, but I really wanted to pay myself the annuity. So what I can say is I'm going to see if I can recreate this annuity myself by taking $223 million, write a check to put it in my account, but write a check to myself today for $7.1 million. So I leave in my account $216.6 million because I took the annuity and I paid myself $7 million. I then put that in the bank at 3.65%. I'm going to anchor the 3.65. So if I did nothing else, at the end of next year, I had $224.51 in my account. But I'm going to pay myself again $738. I'm going to tour the world every year, and it cost me $7 million to do it. So now this is now modeling that this money in my account that I earn 3.65%, and then I withdraw my annuity. And look what happens if we take this down to the 30th year. In the last year, I had just enough money to make that last annuity payment. So what it means to have being different between the lump sum and the annuity, because they have the same net present values, is because at this discount rate, I could completely recreate the annuity with the lump sum. And now my decision becomes that, well, you know what if I can invest my money at 4%? I'm just going to plug it there because I think these are tied to this, right? So if I can invest my money at 4%, now if I look down here, it's clear I want to take the lump sum because I can take the lump sum, recreate the annuity, and have $33 million left over in 29 years. Or what we can do here is to say, what if my discount rate were 4%? That clearly shows that the lump sum is better. In present value terms, I have an extra $10 million left in present value terms. So anytime the discount rate is above 3.65%, say it's 10%, the lump sum definitely has a higher net present value. So that gives you an idea of what that discount rate means and what the IRR means. The IRR is the interest rate that makes you indifferent between these two. And let's do our last example using NPV and IRR. Let's talk about your decision to go and get an MBA. Suppose you're 24 years old today, happy birthday, and you're considering starting an MBA program real soon. It's going to be the next 2 years. It'll cost you $20,000 per year after your fellowships and expenses and travel expenses and things like that. Let's say you're currently making $65,000 a year, and that's expected to grow at 3% if you don't even get an MBA. However, if you graduate with an MBA, you'll make $95,000 a year, and that'll grow 4% a year until you're age 65. Let's use a discount rate of 4%. Let's see what is the value we created possibly by getting an MPV and see whether it was actually worth it. So let's do our cash flows. Assume at the end of the first year, I have to, if I don't get an MBA, I still have a decent job. I'm making $65,000 a year. That's then going to grow at 1 plus 3%. So these are my cash flows if I don't get an MBA. Looks like you have a pretty good life. However, if I get an MBA, I'm going to spend $20,000 today. I'll spend $20,000 next year. Then I'll make $95,000. Then that $95,000 will grow at 1 plus my 4% salary growth of MBA, post-MBA salary growth. Right, you're much more valuable. You can get bigger raises. You took the negotiations class. You know how to get your raises. So now you have these cash flows. Now we can calculate the NPV and just take the difference. If I take the difference between 3.2 million and 2.126. Notice these are just NPV formulas. It looks like I created a value of $1.1 million. The decision to go get an MBA created in present value terms, $1.1 million. Now another way to getting that, if I just take the difference between MBA minus no MBA, copy that down and take the NPV of the difference, I also get the 1.129 million. So by taking the NPV of a difference, what you wind up getting is the value created by taking this decision over this decision. In other words, the MBA over the no MBA decision. In the last few minutes, I want to talk about is something called modified IRR. Now, modified IRR is as widely used in corporations, and the reason why they use it is they feel like they want to capture the fact that they often have to reinvest money at a different rate in which they borrow money. So if we look at our simple MIRR decision, our MBA decision, the modified IRR, and I'll show you the calculation here. Excel has a function, MIRR, where you put in the cash flows. Here are my cash flows. And you put in something called the finance rate. That's the rate at which you can borrow at. And then you put in the reinvestment rate. That's the rate you can invest excess cash flows. And the way the modified IRR calculates, it tells you the IRR, the investment, assuming that anytime you had to expend money, it was financed at the finance rate. And anytime you got extra money, right, this extra money right here, you're able to reinvest it at 7%. Now, you don't have to know how exactly to get to calculate it, because in the future, you can just use the MIRR function. But let me just show you how it does it. And I did an example here. The modified IRR takes the present value of all cash outlays, discounted at the 4%. So notice I'm taking the present value, discounted at 4%. And then it takes the future value of all the extra cash flows that you generated from this investment. And then it invests it, assume you invest it out to 65 years. So I have a formula here that calculates if I had $26,000 at the end of 6 years, and that grew by 7% for 38 more years, I'd have $340,000 from that year's cash flow, and so on. So the present value of all the outlays discounted at the finance rate are $162,000. The future value of all the positive cash flows reinvested at the reinvestment rate. So you put it in a retirement fund that's earning 7%. And then I back into what rate of return would I get if I paid $162 today and got $11 million in 65 years. It just so happens to be that future value over the present value to the 1/41 power. And that's how it's calculated. So in this topic, we've talked about net present value and IRR and how they're used to evaluate financial decisions. Now we used all the examples were personal finance. In the next topic, we're going to talk about how we can apply these to business decisions.